Here we'll work a word problem, but we'll work it two different ways. We'll work it once using pictures, and then work it again using algebra techniques. In this question, imagine that you have an uncounted pile of jelly beans, and we split the pile equally among yourself and two of your friends. If each of you have 20 jelly beans, how big was your original pile? Let's start by drawing some pictures. I'm going to draw 3 stick figures, one for yourself and one for each of your 2 friends. I'm going to draw a circle. Imagine that circle is your pile of jelly beans, and each one of you gets an equal share of the pile of jelly beans. This means we're going to need to split this pile into 3 parts because there are 3 people. This means we'll divide it into thirds, and each of us are going to have 20 jelly beans. This means you get 20 jelly beans, and each of your friends all get 20 jelly beans. Now our question asks, how big was the original pile? We've split it into 3 pieces that are 20 jelly beans each. So if you look at the pile, we could add together all of our pieces of the pile. We could say 20 for you, plus 20 for both of your friends, and add them together. If we take 20 plus 20 plus 20, we will get 60. This means our original pile was 60 jelly beans. We could get the same answer, though, by using algebra. To get started with our algebra, we might realize that we still have 3 people. If we have 3 people, that means each person will get 1/3 of the original pile. We also know that we're getting 20 jelly beans each. Using this information, we're going to write our own equation. We're going to start by putting 20 beans on the left side. And we're going to say that this is the same as every person getting 1/3 of the pile. So we'll put an equal sign up next. Now, we're going to write that 1/3, and then notice the word of comes after it. Usually in math, the word of stands for multiplication. Anytime we want to multiply something, we're going to put a star next to whatever comes next. So I'll place a star next to that 1/3. Then, after the word of, we have the pile. Now this pile of jelly beans, imagine we hadn't already solved it by the picture, and imagine we didn't know how big it was. So since we have an unknown there, we can represent that with a letter when we write an algebra equation. It doesn't really matter what letter we use. I'm going to use X here. So now, by putting together these 2 pieces of information, the fact that we have 20 beans each, and every person got 1/3 of the pile, our equation now says 20 equals 1/3 X. Now all we have to do is solve for X, and we'll be able to figure out how big the pile was. In order to do this, we may have to do an algebra maneuver that not every student has seen up to this point. We have a fraction next to a letter. When you have a fraction next to a letter, you will multiply on both sides by the reciprocal of that fraction. What do I mean when I say reciprocal? If we look at our fraction, we say 1/3. To take the reciprocal, we switch the top and the bottom. When we switch at the top and the bottom, we'll get 3/1. We're going to multiply now on both sides times 3/1. The reason why we do this is that if you have 1/3 and we're multiplying by its own reciprocal, a fraction times its own reciprocal cancels out. This means now on the right side, My 1/3 and my 3/1 will cancel out. This will leave me with just x on the right, and on the left I'll have 3/1 times 20. We could take 3 divided by 1 times 20 in our calculator. We'll say 3, hit the division key, and then say 1, press equals, and you notice that we still get 3. Any number divided by 1 will not change that number. Then we multiply times the 20 and press enter, and we still get the 60 that we expected. Now, this may seem like too drawn out of a process for a problem that we solved fairly quickly with a picture. But what would happen if we had a harder to compute number with a harder to compute picture? We may run into instances where there could be a picture that we can't draw at all very well. I'll give you an example of that next. Now let's do a variation where I split that pile of jelly beans equally among myself and 6 of my friends rather than just 2, and that each of us now have 17 jelly beans. This would be fairly difficult to draw a picture of. We'd have to take a pile, section it into 7 sections, one for me and one for every one of my friends, and then add together that many 17s. But with algebra, we can make this a little bit more manageable. We can write down that we have 7 people. That's me and all 6 friends, and each of us getting 17 jelly beans. To put this another way, we can say 17 is 1/7 of the pile. We can use the sentence we just wrote to write an equation. We'll begin by writing 17, and then notice that I used the word is here. Is stands for an equal sign when you translate it into math language. So I'll put an equal sign next. Next comes the fraction, 1/7. And then, as we said earlier, the word of stands for a times sign. I'll place a star next to the 1/7, and then we mention the pile. The pile here is unknown because we haven't drawn a picture of it yet. So we'll use a letter to represent that. I'll just use the letter X again. So now our equation is 17 equals 1/7 X. Now, since I have a fraction next to a letter, I will multiply by the reciprocal of that fraction. The reciprocal of 1/7 will just be the reversed version of that, and that's 7/1. With that in mind, let's rewrite our formula. We'll have 17. We'll multiply on that left side by 7/1. And then we'll say equals. We'll still write 1/7 times x, and then multiply on that side by 7/1. We bear in mind that a fraction times its own reciprocal will cancel out. That means we can cross out the 1/7 and cross out the 7/1, leaving only x on the right. That's good because we want x to be alone in order to solve this. However, on the left side, we now have 7/1 times 17. Now, we could leave out that over 1 if we felt like it, because dividing by 1 does not change the answer. If you do want to enter this in the calculator, that won't hurt anything, though. We'll go to our calculator and say 7 divided by 1 times 17. We'll press the 7, press the division symbol, then 1, press enter to prove to ourselves that that's still 7, and then times 17. When we press enter, we find that we have 119 jelly beans in our original pile. So we'll say x equals 119. Notice how I wrote x on the left here rather than the right. That's okay. That doesn't change your answer either. If you choose to write 119 equals x, that's the same thing. so don't be too alarmed if you see me switch the order.